Hello, everyone. This is my mid-exam report. The headline is about basics of IoT. First, let's see the requirements of this exam. From this, if we want to finish this exam, we need ESP32 and two DHT22 sensors. I will place it by DHT11 and one LED and one mobile phone. Then we also need to write a C++ program in the Arduino and create a dashboard with the following specifications on Singer. Then we can see the collect during the electronic components from this picture. For LED, the anode pin is connected to D18 on the ESP32. This is the positive side of the LED, where current enters. The cathode pin is connected to GND on the ESP32. This is the negative side of the LED. For the sensors, VCC pin is connected to 3V3 on the ESP32, providing 3.3 voltage power to the DHT11 sensor. GND pin is connected to GND on the ESP32, providing a ground reference. One pin of the data pin is connected to D4 on the ESP32. Another is connected to D5. These pins are the data output from the DHT11 sensor used to read temperature and humidity data. Second, we will see the program using C++ in Arduino step by step. This includes the single ESP32 library, which provides the necessary function to connect the ESP32 to the single-point I/O platform, enabling IoT functionality. This includes the DHT library, which is used to interface with DHT11 temperature and humidity sensors. This defines the single-point I/O username 高玉兰1987 and defines the device ID 高-IoT-ESP32 used to identify this specific ESP32 on the single-point I/O platform. This defines the device credentials for authentication on the single-point I/O platform and defines the Wi-Fi network SSID to which the ESP32 will connect. Then defines the Wi-Fi network password 12345678. This creates an instance of the single ESP32 object called SIN, using the defined username, device ID, and credentials to connect to the single-point I/O platform. It defines the pin 4 and pin 5 where the DHT11 sensor is connected. It specifies the type of DHT sensor being used, which is a DHT11. It initializes a DHT object to interface with the DHT11 sensor. It initializes serial communication at a baud rate of 115200 for debugging purpose. It sets pin 18 as an output. It connects the ESP32 to the specified Wi-Fi network. It initializes the digital sensor. It registers a resource on single point I/O to control the LED connected to pin 18. It registers a resource on single point I/O to send the temperature reading from the DHT11 sensor. From this function, we can read the temperature from the sensor DHT11 and set the parameter of the number to the temperature value, which might be used elsewhere in our application. It calls another endpoint, presumably to send the temperature value to storage. It is used for debugging and monitoring, putting the temperature to the serial monitor. This number function is set as the handle for the humidity endpoint of the same object. From this, we can read the current humidity level from the sensor DHT11 and assign the humidity value to the out parameter, which could be used elsewhere in our application. This line sends the humidity value to another endpoint in order to store. These lines print the humidity value to the serial monitor, prefixed with a label and followed by a percentage sign. It handles communication with the single point I/O platform, ensuring the resources are updated. It introduced a 100 microseconds delay between each iteration of the loop. This function covers the time it takes for the sensor pin to return into the measurement in centimeters. The speed is approximately 29 microseconds per centimeter. Now, if the single ESP32 and the mobile phone are connected, we can see the control interface of two sensors and the LED nexus. Through this video, we can see that the LED can be controlled by the button on this control interface. And we can see two values of humidity. At the same time, we can see two values of temperature. Now, we create the dashboards of LED. We enter LED to name the title. Choose the on or off state and the blue color for it. Then, choose the source of data. Next, we create two dashboards of humidity. We enter humidity to name the title. Choose the tachometer and purple color for it. Then choose the source of data. The sampling interval set 20 seconds. The range values is from 0 to 100. Then we create two dashboards of temperature. We enter temperature to name the title. Choose the donut chart and red color for it. Then choose the source of data. The sampling interval set 20 seconds. The range values is from 0 to 100 sensors. Finally, we create data buckets for these sensors. From these pictures, we can see that we have created two data buckets to collect the home date values. Through the two pictures, we can see that the home date values are different from different sensors at the same time. From these pictures, we can see that we have created two data buckets to collect the temperature values. Also, we can see that the temperature values from different sensors are different. About the integration process on the sensor, we can watch this video. We can see there are two values of home date from two sensors. One LED switch to turn on or off, and two values of temperature. In the buckets, we can see the values in the table. The data is from the last 7 days, and we can see the other value of temperature in the table. Is also the data is from the last 7 days. We can see the home date values. And we can see the other value of home date from the other sensor. We can see the dashboard like this. That's all. Thank you for watching. And please give some suggestions for this report.